Hello all, welcome back to my channel Teja Technologies. So recent times I'm not posted any of the videos because due to some reasons, but in recent times I'm checking my Instagram. I saw one post that is always about this 12 weeks workshop on AWS. So this motivate me to do some kind of workshop in AWS. So I just scrolled down and I saw all the details. So here the organizers he's the organizer Prasad Rao and some other people they are organizing 12 weeks workshop. So it's completely free. So everyone can join. There is no restrictions to join. So what the criteria here they're dividing all the AWS topics 12 weeks. So each week they're gonna focus on a couple of services. First week they're gonna focus on AWS core services. Second week they're gonna focus on identity and access management. Third week they're gonna focus on networking, like that. So, who can join? Like anyone can join. Maybe the AWS beginner can join, or advanced level person. Like maybe they have a good knowledge on that AWS, and they can rectify their knowledge. They can also join. Or intermediate person can join. Architects can join. Everyone can join. They can spend their time on the particular topics for at least a 1 week of time to spend some time and to master the particular services. That is the main agenda of this particular program. So that is the reason this motivate me to do the video on whatever my learnings and the particular workshop. So right now it is in week 3, so it's all about networking. So networking in AWS networking, obviously it's related to VPC. So I thought to do some kind of a video whatever I have learned in this particular workshop and about the challenge what they have given in terms of this particular workshop. If you see this particular post, everyone can join. Maybe I'll also post the links in the description. And here we have a wonderful community. So this is a Discord channel. So here this is community. Everyone can join in this community as well. Like they can ask your doubts, post their questions, so they can form a team and they can do a couple of things, knowledge sharing, everything they can do whatever they want based on this particular channel is located around the world. It's not only limited to India, UK, US, a couple of other countries also, other country people also there in this particular channel. So if you follow this particular channel also, you will get good knowledge in terms of good community. So, and this is the 12-week challenge. So, in this 12-week challenge, the sponsors this Vizlabs. So, what this particular Vizlab sponsoring, it will give you a what is premium access to the sandboxes, AWS Vizlab. Like they have some lab setups. So, whoever participate this 12-week challenge, and they'll be considered they have a team, this 12 week challenge team, they have a team. Whoever wins top 15 performance, what how they will calculate this top 15 performances. So either you need to write a blog about whatever you are learnings. Maybe if you see the point here, so the point here, see, you need to create a blog or a medium, github pages, or any of the things, or a LinkedIn post, or you need to create a video for whatever you are learning. So that they're gonna there is a committee, so they're gonna check your post, they're gonna check your uh, whatever your learnings, how accurate you are doing everything, and whoever wins, right, they're gonna get 6 months premium access to the Swiss Lab access, so that you can increase your learning capacity. So if you see in AWS, we have only a couple of services only free. So that if you go for a practice, couple of other services, you need to spend some money. But when you win this particular challenge, you have a 6 months time, premium access subscription, so that you can practice more and you can learn more. So try to participate if you have a time. Try to participate. Everyone can join. So I'll also post all the links in the video description box. and this is the person like Prasad Rao. He's the organizer, and couple of other people also organizing the same challenge. They are also maintaining the same challenge. Okay, so I'll also give couple of other people LinkedIn's as well. And this is my LinkedIn. If you want, you are guys already aware of it. This is my LinkedIn. If you want to follow, you can also follow me. And if you need any questions about any topics related to VPC or other things, you just ask me or you just inbox me. You just send me a connection request. I'll accept and we can discuss on it. So let's get that's it. I think we can go and we can discuss about other things. Okay. So now this week's topic for this particular challenge, maybe I can make a video about this. Maybe this video, maybe it's not from basic to advanced, but maybe like it's somewhat, whoever already know some concepts about it, I'm gonna discuss about it. But have a brief about the fundamentals about VPC as well. Maybe you just listen carefully. Okay. So first we can discuss about the fundamentals about VPC, what are the components in VPC, why we use VPC. So everything about networking we can discuss, and then we can follow this particular lab sessions. Like we have lab 1, lab 2, lab 3, lab 4, 4 labs we have. And we start with multi VPC account architecture. This particular lab we will go in a start and we'll create this and we'll do that. Okay. So now what we're gonna do now, so I have make some PPT presentation for you to understand more in terms of VPC and everything. So we start with VPC. So I'll make this one. So what is VPC? So whenever we are talking about VPC, VPC is nothing but virtual private cloud. So it's a Amazon, it's a kind of service in Amazon used for the networking. Okay. So Amazon Virtual Private Cloud, Amazon VPC. It's a service offered by Amazon Web Services that allow you to create private isolated network in the AWS cloud. Within VPC, you can launch AWS resources like EC2, RDS, and more into the logical isolation of the AWS cloud. What it means? So VPC is nothing but like it's a kind of a network or network service that is provided by AWS. That's fine. We understood. After that, like maybe if you're trying to figure out an application or like an infrastructure need to use an isolation network, so that time you need a dedicated network for your application, then you can create your dedicated isolated network, then you can create one VPC for your application. So that is what they are saying about it, all about it. So this is the definition about VPC. You can take a look about the definition about VPC. So you can launch any number of the resources into your VPC, and we will gonna talk about like what is VPC. So VPC is this is all about, and apart from that, like what are the components that is involved in VPC also we're gonna see, and like there are many components involved in VPC. So we are not gonna focus on all the components at this point of time. Maybe we can discuss a couple of components, and when we go to the lab sessions, maybe we can discuss a couple of other components as well. Okay. So here, like, why we need VPC? Like, when you have a point, like, why we need VPC? So, when we need a point, like, we need to have a network isolation. There are points why we use VPC. So, to control and customization, we need a VPC, and for the security purpose as well, we need a VPC. So, to secure our application, to secure our infrastructure, we need a VPC. Scalability and resource isolation, as we mentioned about resource isolation, network isolation. So for this reasons, maybe these are the couple of reasons, but there are other reasons as well to use VPC. Okay. So if you're talking about the main components of VPC, like we have a IP address range, that is CIDR block, and we have a subnet, and we have a route table, we have an internet gateway, We have a NAT gateway, we have a security groups, we have a NICLs, network access control list. So there are a couple of components are available in VPC, but we're going to discuss these main components for this particular video or for this particular demo. And like later videos, like we can have a discussion, detailed discussion about other components and other examples as well. So maybe if I can just check in the Google. So if you go to Google and just check VPC components, just I'll click on the image. I'm just checking for the components in VPC. Okay, VPC components in AWS maybe. Let's check that to tell you what and all the components are involved in VPC. Okay, I'm just having one diagram. So it's fine. So we have like n number of components. Maybe I can show you here. This third week, I'm on a third week, and I start with here. I have a function of fundamental topics. So here in fundamental topics, like we have seen here, like the fundamentals like AWS, VPC, subnets, NACLs, route tables, internet connectivity, VPC endpoints. So this is easy instances. Like this is the resource that we're gonna launch inside a VPC, but this is not a fundamental for a VPC, but this is resources that we are going to launch inside a subnets or like VPC. Okay, that is different. So then, like we have a concepts called VPC pairing, transit gateway route tables, and we have an NACLs and security groups and endpoint policies. So then we have a CloudWatch, VPC flow logs. There are multiple components involved in it, but what we're gonna focus in our particular demo, right? We're gonna discuss about the few components of VPC right now, and rest of the components we're gonna discuss whenever we are doing a live demo for the particular topics. We're gonna discuss that later point of time. So why? Because like VPC is a kind of a lengthy topic. So at this time, we're gonna uh, discuss a couple of things and we do a practical demo on it, and then we go by next component to discuss, and then like we do a demo on it. Okay. So right now, if you see, these are the fundamentals. Like whatever the fundamentals here, I just mentioned. I just created a PPT out of my knowledge, or like I just followed some definitions, and I just created a PPT. And once we have done a basic things, like we can follow here and we can start with this lab one. Okay, so let's get started. So we're gonna discuss about VPC, right? Like VPC have a couple of components. The main components are like IP address range, subnets, route tables, internet gateway, NAT gateway, security groups, and network access control list. These are the main components. Okay. So we're gonna discuss one by one. What is the CADR black? What is the subnets and each and every one. So if you take an example of CADR range, so the CADR, like the full form of this CADR, classless interdomain routing range, is used to define the IP address range for your VPC. So this CADR, what it will do, like your VPC, you have a VPC. For this VPC, it will design like how many IPs you're gonna allocate for this particular VPC. That is gonna decide the CADR range. So if you take some number, right, maybe 100, 200 for your VPC IP addresses, the CADR range will decide how many IP address gonna for your VPC. That is the main point. So the CIDR range allow you to specify the size of VPC and the number of IP addresses it can accommodate. Okay, the size of the VPC and the number of IP addresses that can be accommodated. It's a way to effectively allocate IP addresses to your resources within the VPC. So it's a kind of efficient way, we can say, to allocate the IP addresses to the resources. So IP4 CIDR ranges, if you see the particular format of this particular thing, like we have XSX/Y. So basically how it is gonna divide it. So they have a basic base IP addresses of VPC, and Y represent the number of significant bits, maybe 16 or 24. So we're gonna see next slides how we decide the range of CIDR, how we're gonna divide subnets and each and everything. We're gonna discuss about it. Okay. So if you take a simple example, if you specify the CIDR range 10.0.0.0/16 for your VPC, it means your VPC have IP addresses of like IP addresses range from 10.0.0.0, and it can accommodate 2 power 16. So how this 2 power 16 will be calculated, and 65,536 IP addresses will be allocated to this particular VPC means, like we have a formula. What is the formula? 2 power 32 minus n. So here n represents this particular 2 power 16. So 2 power 32 minus 16. What is the value? 2 power 32 minus 16. Like we have a 2 power 16. 2 power 16 value is 65,536. So if we take a complete set of VPC, so if we mention here 2 power 16, it is 65,000. What is that number? 65,536. 536 IPs. So inside this VPC, you have allocated this many number of IP addresses. You can use it. Okay. So this many IP addresses inside your VPC, you can use it. That is what CIDR range. So we have another concept called subnet. Subnet means, so we just divide it. Maybe one subnet, two subnets, three, four. So inside your VPC, you're gonna divide your IP addresses into subnets. So why the subnets? To have a logical like division, like you have 100 IPs, like all 100 IPs you're gonna not use at once. Okay. So in the same way, is 60,536 IPs, you're gonna divide multiple subnet associations so that each subnet have some minimal IP addresses. Whenever you have a need to use couple of IP addresses, you're gonna launch resources in your particular subnet. So that's how you can assign the IP addresses as per your requirement. Okay. So we're gonna decide, like we're gonna discuss about what is a subnet, what is a subnet definition, and examples. Everything we're gonna discuss, but you just remember, like VPC is a whole unit, like kind of a parent unit. Inside this subnet is a kind of a child unit, wherein parent unit have more number of IP addresses. To divide this more number of IP addresses, we have a subnets. These subnets only have a limited number of IP addresses. To isolate, like to divide more number of IP addresses, so we have divided subnets. VPC we have divided multiple subnets. Now, so next topic is subnets. What is a subnet? So subnet are subdivisions of VPC IP addresses range. So each subnet is associated with an availability zone. So each subnet, whatever we are discussing about here, the subnet, right, particular subnet, it would be associated with one availability zone. So normally in AWS we have regions, and inside regions we have multiple availability zones, right? So this subnet, like each subnet will be associated with availability zone. Like that is a simple point, and can have own CIDR block. So how you have a CIDR block for VPC, the same CIDR block for your subnet also it will be there. Why? Because you are associating your 2 power 16 means like 2 power 32 minus n. In n place you are represented 16, like 65,536 ideal number for VPC. You are dividing this with subnets, right? In subnets, what you're gonna see, you just mention the ideal case for subnets division, right? Maybe you can mention 2 power, I can say 2 power 32 minus, in place of n, n equal to, I can say 24. If you take n equal to 24, so 2 power 32 minus n plus, like we are represented 24, meaning 32 minus 24. How much? So 32 minus, so I'm just calculated here. Here also like we can say anywhere. So 32 minus 24. Correct? Yeah. Now we can have here 2 power 8. 2 power 8 means 256 IP addresses. So this is 256 IP addresses. I think able to see this. Fine. So what it means? So when you take a VPC for the CIDR plan, you have a 2 power 16, meaning 2 power 32 minus n plus you are taken 16. So 65,536 IP addresses allocated to your VPC. In the same time, you just mentioned for my subnet, I need 2 power 8. 2 power 8 in the sense, how it will become 2 power 32 minus 24. 2 power 8, 256 IP addresses. Out of 65,536, 256 IP addresses you are allocating to one subnet. In the same way, if you have a multiple subnet based upon your needs, you can create n number of subnets based on your VPC CIDR block range. Okay, that is like kind of a division. So for now, I have a couple of requirements, like 100 IP requirement I have. So based on that, you can have a calculation here: 2 power n minus 24, or 2 power n minus 32 minus like 28, 27. You have calculated, like for your application you can calculate your CIDR block range for your VPC, for your subnets. You divide it and you can use it. But this is ideal, like 2 power 16 for VPC and 2 power 8 for subnets are like ideal calculations. And next, what we're going to discuss, so we're going to discuss about the route tables. So route tables also one of the important component in a VPC. So VPC contains one or more route tables, so each associated with one or more subnets. Meaning, so one VPC we have like one VPC we have multiple route tables, like maybe one or and like multiple, more than one route tables, each associated with one or more subnets. So when we are talking here, we have a VPC, we have a VPC here, and we have subnets. So in the same way, we have a one more thing called route table. So it's kind of a tabular format, I can say. Maybe we can give like this. mention this. So this is a route table. So for VPC, maybe we have one main route table, and as per your requirement, you can create multiple route tables. So this particular route table, what they're saying here in the point. So VPC contains one or more route tables. So just like here, I just mentioned one route table, but as per your requirement, you can create multiple route tables. So each associated with one or more subnets. So this particular route table may be associated with this particular subnet and this particular subnet and this one as well. Okay. So each route table will be associated one or more subnets. Okay. Route table defines how the traffic is routed within the VPC to the external destination. So what it will do, it will have all the rules, all the regulations, the IP addresses and everything. So from the external side or from the internal to the external side, like all the rules will be, we can say like specify here, we can mention here. So when we are discussing about the demo, we can discuss more about the route table, how we configure, like how we can create a route table, how we can edit the routes into the route table. Everything we're going to discuss about in the particular demo. But for now, you just remember in the route table why we use it to define a traffic flow from external to the internal, like particular flow from the external side to the internal resources in your VPC or resources in your subnet. This route table will decide inside the routes. Okay, that is the main agenda of the route table. So internet gateway, like we have another component called internet gateway. It is also the main component for VPC. Why? Because without this, we can't able to get internet in the VPC. So an internet gateway allow communication between the instances in the VPC and the internet. So by using this internet gateway, we can have a internet communication between the external world to your VPC. Inside your VPC, maybe you are using EC2 instances or any of the servers or databases, right? So you can use internet connectivity from the external to the inside your VPC by using internet gateways. So it serves as a gateway for outbound and inbound internet traffic. Like basically, it serves as a gateway for outbound and inbound internet traffic actually. Okay. So next we're gonna discuss about elastic IP addresses. So when we are talking about IP addresses, we have a public IP, we have a private IP, we have a static IP, we have elastic IP. So elastic IP is nothing but a static IP only. So elastic IP addresses are static IP addresses that can be associated with instances in your VPC. They provide constant IP for your instances with dynamic IPs. Meaning, so when you create any of the EC2 instances, by default, like you will get a private IP and you will get a public IP, two IPs. So whenever you restart or like you terminate, whenever you restart your EC2 instances, your private IP remains same. Your private IP remains same. I'm repeating, your private IP remains same, but the public IP keep on changing whenever you restart, whenever like it rebooted something, right? Your public IP keep on changing. But I don't want to change my public IP keep on. So that time what you're gonna do, you can assign one elastic IP, like it's kind of a static IP. You can assign this particular resources. Whenever you restart your EC2 instances, whenever you restart reboot something, right? Like this particular IP, it won't change. Okay, that is we can call it as a static IP or elastic IP. So this is example, like I can say small example for VPC and the resources and everything. So if you see here, this particular outer line we can consider as a AWS cloud. Normally the diagrams, right, in the AWS side we gonna mention raw.io. All the diagrams will look like. Based on these diagrams, we can assume how we can create resources, how we can create services in AWS. So based on that, like we can get an idea. Maybe slowly we're gonna learn how we can create this architectural diagrams and how we can get a high available architecture diagram. So we're gonna learn in this particular channel. So I have a time. So we're gonna discuss more about this particular diagrams and more about AWS services also in future. So I'm gonna make the videos very clear. Slowly, we're gonna make some progress about the videos, and we're gonna create complete AWS content for free. Okay, lot more workshops and lot more examples, lot more theory content, interview questions, everything we're gonna prepare in this particular channel. Okay, stay tuned. So now we're gonna discuss about this particular architecture. So if you see this outer range, like it's kind of a AWS cloud. So inside in it, like we have a region, the region in US East one, and we have a VPC. So this symbol represents as the internet gateway. As we mentioned, by using this internet gateway, we're gonna get internet to your EC2 instances. Inside VPC, the resources, by using this internet gateway, we get the internet. So as per this availability zone concept, we have a different subnets, right? Public subnet, private subnet. So we haven't discussed public and private subnet. We discussed later point of time, but we discussed about subnets, like the logical identity of division of the IP addresses. We can call it as a subnet. So if you see mentioned here, 10.0.0.0/16, this is a whole VPC CADR range. When you're talking about the IP address range, the particular subnet 10.0.0.0.0/24. And here what we mentioned, 10.0.0.1.0/24. Okay, so we're gonna see how we can do this also in practical. We will see. So the only difference, like we launched two EC2 instances in each of the subnets, but I have a doubt. So I have a subnet, public subnet, and here I have a private subnet. I didn't mention, but it's a private subnet. Why? Because like it's a green color and it's a blue color. There is a difference. So why we mention like this means, so when we have internet, like in the public subnet, by using internet gateway or by using route table association, you can have internet connectivity in your AWS EC2 resources. But here, whatever the resource we have in the private, like this is a private subnet. Inside private subnet, we don't have internet connectivity. So when we attach the internet gateway to the private subnet, it become public subnet. So that is not possible. There is another solution how we can get internet in your private subnets by using NAT gateways. You can have internet facility, outbound internet facility in your private subnet EC2 instances for maybe patching or any kind of a package download. So we're gonna discuss that also in the demo part. Whenever we are gonna discuss about the demo, we're gonna discuss more details about in the demo as well. Okay. So now, so this is a this particular architecture, like how we can create. These are the steps I just given. Maybe if you want, you can take a screenshot of it. But in this particular video, I'm not going to discuss about this particular demo. I'm going to discuss about the demo regarding 12-week AWS workshop challenge, right? We have there, like we have a couple of labs. So I'm going to discuss about this particular labs. But if you want to try this one as well, you just take a screenshot about this one also. You can try from your side. And in future, I'm also going to make the videos about how we can create this particular architecture, and you can compare with this and you can check as well. So you can take the screenshot. So NAT gateways and NAT instances, we're going to talk later. Okay. Uh, we already talk basic details about it, but in depth, we're going to talk inside a demo part. I'll minimize this. I'll minimize this one also. Okay, keep 100. Yeah, I think now you guys able to see the screen. So networking immersion day. So this is a weekly workshop that I'm going to follow. Here, if you see, as a beginner or an intermediate level, you can able to start any of the demos here. So I'm gonna start with this particular demo. Maybe I'll close all the remaining things. Like these and all I don't require as of now. So I'll just remove it. Okay. Yeah. This LinkedIn also I don't require now. If you want to follow, you can follow here. I'll give my LinkedIn account also in the video description, and the particular organizer's LinkedIn also in the video description, so that you can follow them. And if you want to do participate in this challenge also, you can participate at any time. There is no restrictions about it. Right. So in this, we have concepts called beginner topics. We're gonna start with beginners, and we're gonna start with lab one, and then we followed by lab two, lab three, lab four. Based on our time for this particular week, we're gonna start this labs each and every one, and each and every video I'll try to upload in my YouTube channel. Okay. So we're gonna start with this particular lab. What they're gonna see here, like if you see the architecture, they're asking us to create three VPCs: VPCA, VPCB, VPCC. And inside in it, like if you see here, like we have availability zones, two availability zones here, 1A, 1B, here also 1A, 1B, here also 1A, 1B, six total, six availability zones. And we have here internet gateway. This symbol represents internet gateway. Here also one internet gateway, here also one internet gateway. But how we gonna follow this demo, right? We're gonna read each and every instructions here. Like AWS given a fantastic documentation here. We're gonna read step by step documents, and we follow this particular demo here. Okay. Now, so lab one, multi VPC account architecture. So in this particular demo, Amazon Virtual Private Cloud VPC lets you provision a logical isolation section of AWS VPCs where you can launch AWS resources and virtual network that you can define. You have a complete control over the virtual networking environment, including selection of your own IP addresses range, creation of the subnets, configurations of the route tables, network gateways. You can use both IPv4 and IPv6 in your VPC for secure and easy access to your resources and applications. So they gave just a basic about what is VPC. We just discussed about it. So as of now, we are going to discuss about IPv4 addresses only. But if you have a more interested, like what is the difference between IPv4 and IPv6, we're going to discuss like in future all the details about it. But you can check what is the difference between IPv4 and IPv6 also. And then what they're saying, like availability zones are multiple isolated locations within the each region. So we just mentioned here this particular one. I can say like US East is a region. Inside in it, like we have a multiple availability zones. This is 1A, one availability zone, 1B, one availability zone. If you see here, this is loading here. So here, if you see, all these are the regions. Okay. So in the demo, what they are saying, US East, US East, US East, US East. Okay, not Virginia. So an internet gateway is a horizontally scaled, redundant, highly available VPC component that allow communication between instances in your VPC and the internet. It therefore imposes no available risk or bandwidth constraints over your network traffic. Okay, whatever we are going to discuss, this is internet gateway. Using this internet gateway, so inside our public subnet, we have EC2 instances. So this EC2 instances to access internet by using this internet gateway, we can able to access the internet. That is what they are saying about here. In this lab, what we're gonna do, we will create three VPCs: VPCA, VPCB, and VPCC. We're gonna create three VPCs with internet gateways. Okay, internet gateways. This is a symbol for internet gateways and EC2 instances. Okay, Amazon EC2 instances. This is a symbol for EC2 instances. One one per VPC. Okay, EC2 instances one per VPC. Okay, okay. We will be observe that by default EC2 instances and different VPCs are not able to communicate with each other using a private IP addresses. So this EC2 instance and this EC2 instance and this one, like we have different EC2 instances and different VPCs. Okay, what we're gonna observe here, we're gonna able to access the internet inside this by using internet gateway. But from this particular US East 1A, we're gonna access EC2 mission in US East 1A of VPCB, meaning a mission in VPC A, we're gonna access to VPCB. So we're gonna try with by using a private IP addresses. So whether we're gonna establish a connection or we're gonna get a timeout error. So if you get a timeout error, how to solve this? Everything we're gonna discuss about it. Just we are trying to make a call from here to here. If we are trying to able to access this mission, or if you are trying to access communicate with this particular mission, so we're going to check it by using a private IP addresses. If it is not going to work, how we can have a connect? Maybe we can have a, like here we have a peering connections. We can see how we can establish communication between these two VPCs. Those kind of things like we can discuss in the later part of this particular demo. Okay. This is architecture about it. We're gonna create three VPCs: VPCA, VPCB, VPCC. With this is one what is like CADR range. This is CADR range, and this is CADR range. So next, we're gonna go to next. So here we have 1.1 create VPCs, subnet, and EC2 instances. So before we're gonna start, like we have active AWS account should be required to do these demos. So I have AWS account. So you can use the free tier AWS account as well. And once you create, and here also you have a cleanup. If you see 1.4 cleanup means like we can also clean all the resources whatever you created. You can terminate it, like we gonna create fast. And once this demo is done, so I'm gonna show you like how you can terminate all the resources for this particular demo, how you create, how you gonna terminate the seasons, like to avoid extra building. So 1.1, we're gonna create, like if you see here, VPC name, VPCA, VPCB, VPCC, and this particular CIDR block range, and this is the availability zone. Like we can mention each VPC, we have a two availability zones. In these two availability zones, like we have a subnets, like two subnets. These subnets, like this is CIDR, this particular CIDR range for this subnets. This is VPC CIDR range. This is subnet CIDR range. I'm gonna show you how we can create the VPC. What is the CIDR block for this one? Like everything we're gonna see in the demo. Okay, and create VPCs. First step. Our first step to create VPCs with non-overlapping CIDR block. Okay, we're gonna create. So non-overlapping means in the sense like we don't overlap VPCA to VPCB, VPCC IP addresses. Right. That is the reason. If you see here, 10.0.0.0/16, here we are just mentioning 10.1.0.0/16. Here also we are mentioning 10.2.0.0/16. So the IP addresses here is different, the IP addresses here is different, the IP addresses here is different. It starts with different. Okay, here also we get 65,000 IP addresses, here also we get 65,000 IP addresses, here also we get 65,000 IP addresses, but it won't overlap. Why? Because the series we have taken, it's different. Okay, so if you're gonna go to the dashboard, VPC dashboard, so I'm just opening my AWS account. So if you have AWS login credentials, you just open your AWS login credentials. So in the search box you can type VPC. So you have services. Inside these services you have you can open directly the VPC dashboard. So this is a VPC dashboard. So if you see all the services about VPC, all the components, how we can use each and everything will be there. So maybe we can discuss one by one the components and the demo. We are not going to discuss each and everything today because it's kind of a lengthy discussion for a networking and VPC. So that is the reason like AWS itself, like it created one default VPCs, like whoever like creating an initial user or like they don't have any networking knowledge or something like that, AWS by default each and every region it will create a default VPC. So default subnets it will create, so that like you can directly launch, you can use the directly that default VPCs, you can launch resources if you don't know. But slowly we can able to learn how we can create our own custom VPC, how we can own your custom subnets, how we can design our architecture, everything we're gonna learn now. Okay, So when we are following this particular demo, what we're gonna do? We're gonna create three VPCs. So we will do that. So here we have steps. So VPCA, select a VPC only. So I can say maybe what we can say, we can follow the documentation and we can follow this one as well. Side by side, we can do that. Okay. So here I have a VPC dashboard. Here I have a documentation from AWS side. So I'll give this link as well. Here, if you click on third week workshop, you can go directly here, and you have lab also. So I'll give the link anyway in the description section. You can follow this documentation step by steps. You can also achieve the same output whatever I'm getting it. Well followed up. Okay. So first create a VPC. So I'm gonna create a VPC. So I'll click on create VPC. So next what we're gonna see VPC only, and we're gonna give a name VPCA. Okay, VPCA. So the name what we're gonna see VPCA, and we're gonna select here IPv4 CIDR manual input. Like the particular CIDR we're gonna give. So what CIDR range we're gonna give here? Like if you see this VPCA, we have a 10 dot 0 dot 0 dot 0 slash 16. So we're gonna give this particular, like we are following this particular demo. So that is the reason you are giving this range 10 dot 0 dot 0 dot 0 slash 16. So tenancy I can say default. I can follow here. Okay. So see the same thing. Tenancy they can put the default, and tags they can say name and VPCA. You can also put name and VPCA. Okay. Then you can have a create VPC button. You can create a VPC. So what they mentioned, repeat the same steps to create a VPCB and VPCC. See the table 1 for the details. After completing these steps, you should be have three new VPCs and default listed under our VPCs. Okay, this is the default and three VPCs. So we first, as of now, we just created VPC1. I can show you. I'll go to the VPC dashboard and VPCs. So if you see VPC1 we have created, this is the default one created by the AWS. So what they are saying now, in the same way how we created VPCA, in the same way you can create VPCB and VPCC. So follow the same steps. Okay. So we're gonna go here, create VPC. Okay, VPC only we're gonna create. And what is the name? VPCB. And what is the CIDR range? So CIDR range for the second VPCB 10.1.0.0 slash 16. Okay, we'll mention the same 10.10.1.0.0 slash 16. Okay, and the remaining everything, the details are same. Tenancy is the default and name VPCB and create VPC. We just created second VPC, and again they repeat the same steps. Create VPC, VPC only, VPCC. So VPCC, what is the CIDR range? 10.2.0.0.0 slash 16. Okay, we're gonna put that range here. 10.2.0.0 slash 16. And we have IPv6 CIDR range. Tenancy is default, and we have a name VPCC, and we're gonna create VPC. So we created three VPCs: VPCA, VPCB, VPCC, and we have a default VPC. Total four VPCs. So if we follow the documentation here, that is what they mentioned here. We can create uh, here down. So VPCB, VPCC you can create by using this CIDR, and after completing these steps you should have three VPCs and default listed your VPCs. We can check this VPCs. In your VPC dashboard, if you go here, so VPCA, VPCB, VPCC, I have three VPCs and the default VPC. Okay, we're gonna go next. So now we created VPC, fine. So once we created VPC, if you see this diagram, we have a availability zones. In each availability zones, we are creating two subnets. So we're gonna create now. What we're gonna create now? We're gonna create subnets. How we create a VPC in the same way we can create subnets. Why we are creating subnets? So okay. Anyway, you created VPC, but isolation for your IP addresses, like based on your application resource availability, IP addresses division, right? You're gonna create multiple subnets. So each in like different availability zones. Maybe for high availability, I can say. So multiple subnets you can create. But here, as per the demo, we're gonna create two subnets per each VPC. So if we say here two subnets we're gonna create in VPC A. How to create it? So here we have a steps. You're gonna navigate to your VPC subnets. So if you go here subnets, so we can create a subnet. So first we need to select your VPC ID. So first I'm going to create a which VPC you're gonna create a subnet. If you see this particular demo, first VPCA we're gonna create two subnets. So VPCA. So if you see here VPCA and the subnet name, what name? Like we can follow here documentation, each and everything they are mentioned clearly. So the name VPCA AZ1 they mentioned. So same name we can put VPCA AZ1. So you can give any name, like it's not the thing like you need to give the same name what they mention in the documentation, but to avoid a confusion, like you are using first time, right? Like as per the thing, right? To avoid a confusion, like maybe this VPC name, like we might use a different place. So that is the reason to avoid a confusion, like we are giving same naming conventions. So availability zone, like US West. This is the particular availability zone they mentioned. We just check it whether it is there or not. US West. So we have all this one. So as per the document, they mention 1A, 1B. So here they just mention different availability zones. Okay, West some region based on this, how it will come, right? Whichever region you select, based on that, the availability zones will come here. So they use different availability zones. It seems, but here we can just put 1A, US East 1A. We can put this one, and this is by default. And we're gonna put the subnet IPv4 subnets ADR plug. We're gonna put now. So what is the range they mentioned here? 10 dot 0 dot 0 dot slash 24. Like we're gonna input the same thing. 10 dot 0 dot 0 dot 0 slash 24. So if you see here 256 IP address IP it will come for the subnets. So name same VPCA AZ1. Okay, and create a subnet. That's it. And that's it. Here also same steps, create a subnet. So we created one subnet. So the same way repeat these steps, above steps, create subnets for VPCB and VPCC, refer the table 1 for CIDR. After you finish this task, 6 new subnets should be available. Okay, we need to create 6 subnets. So we're gonna follow this diagram. Based on this diagram, you can create it. So first subnet we created. We're gonna create second subnet in VPCA. Okay, create a subnet. Which subnet we're gonna VPCA we need to create, and what is the name for this particular subnet? We can give which name we can give, like we can have a naming conventions here. We give VPCA AZ2. Okay. VPCA AZ2. Okay, region 1B we can put, and the CADR range also we gonna check here and we can get it that. So 10 dot 0 dot 1 dot 0 slash 24 we can put that. 10 dot 0 dot 1 dot 0 dot slash 24. Don't confuse. Here also 256 we can create subnets. Okay, so now you created two subnets. two subnets, and VPC A, you created two subnets. In the same way, another two subnets in VPC B you have to create, another two subnets in VPC C you have to create. We'll do that. So VPC B, I'm going to create one more subnet, and the name for VPC, sorry, VPC B, and AZ1, I just mentioned AZ1. And the CIDR range we can have here 10.100/24. We have to give that here 10.1/0.024 256 IP addresses. Okay, we are creating another subnet. We're gonna create one more subnet in B, VPCB, and AZ2. Okay, and we're gonna create in 1B, and this ADR range like 10.110/24. Okay, we're gonna give that 10.1.10/24. We can say like this CADR black, you can calculate based on that, and you can give different range also, but we are following this particular demo, so that is the reason we are giving this range. So create subnet, I created VPC also, VPC. So VPCA, two subnets, VPCB, two subnets I have created. For VPCC, two subnets I have to create. VPCC, first we can create it. VPCC and AZ1 and 1A. What is the CADR range here? So we have 10.2.0.0./24, 10.2.0.0/24. You have to check this /24, yes. So VPCC agent create subnet, that's it. And we're gonna create one more subnet in VPCC, and here VPCC agent 2, and say 1B. So 10.2.1.0/24, meaning 10.2.1.0/24. We just follow the documents. Okay, just create another subnet. So now we can check it. VPCA, we have two subnets. VPCB, you have two subnets. VPCC, you have two subnets. Okay, here this particular range as well they have given. So this is the range. Maybe here we may get doubt. So 2 power 18 means like we have 256, right? Like why it is showing only 251? For the internal purpose, for the AWS, it will use 5 IP addresses for routing, DNS configuration, for the other reasons. Right? So AWS uses, whenever you create a subnet for internal purpose, it will use 5 IP addresses. Okay, so that's the reason you are able to see only 251. 251 plus 5, total 256. Okay, we created subnets. We're gonna see next subnet, like we did this one. So deploy internet gateway. Now we're gonna see 1.3. What we in this section we're gonna deploy one internet gateway per VPC. We need an internet gateway in order to establish outside connectivity to the EC2 instances in VPC. So as we mentioned earlier, we're gonna connect the internet, right? So that's the reason we're gonna deploy internet gateway. Okay, so here we just see like steps also given, like 1 2. So then here we see internet gateway, create internet gateway. So the name we can mention here. So the name tag what they mentioned, VPCA-IGW. IGW means internet gateway. VPCA-IGW. just like to recognize VPCA internet gateway and then create internet gateway. Just create internet gateway. And next, select newly created internet gateway. Click on attach to VPC. Okay, we see that. So here if you see attached to VPC, like once we create internet gateway, how this communication will work, we need to attach this particular internet gateway to VPC. So in the actions, we can see attached to VPC. Actions, attached to VPC. Which VPC we need to attach? VPC. We can attach any VPC, but the naming conventions, we are going to attach VPC. So attach internet gateway, we are just attaching. I did that. So the same steps. So repeat these steps. Create internet gateways for VPCB and VPCC. You should have an internet gateway default VPC and three newly created internet gateways. Same way we need to create internet gateway and we need to attach each and every VPC. So we'll do that. Okay. So go to the internet gateway. You have create internet gateway. Put VPCB IGW VPCB IGW. Okay. Actions. Attach VPC and VPCB. Attach. Again, internet gateway. Create internet gateway. VPCC IGW. Create internet gateway. Here in actions, attach VPC. You can say VPCC. We are attaching internet gateway. So if you see internet gateway, here we have one default and VPCA, one internet gateway for B, one internet gateway for C, one internet gateway. So this is also done. So updating the route tables. In order to utilize a newly created internet gateway, you need to update VPC routing tables to point the default route tables of this IDWs. Okay, we'll do that. So in VPC, navigate to the route tables. Okay, we're gonna go to the route table. So route tables, we want here. So what we're gonna go here, what we need to do. So assign name to the route tables by identifying what VPC a given route table belong. Okay. Here what they mention VPC a route table. Okay. Route tables. We're gonna check here. So if you see here, if we check this route tables, we have this one. So what we're gonna do, like we have one, two, three, four route tables. Now what they're saying, you need to assign the route table names for VPC based on the VPC name. Like here, if you say VPCA 1, 2. So for VPCA, you can mention VPCA route table based on this detail. If you see this, so if I just mention here, if I see here details down, so this is VPCA. So I can name this one as a what mention VPCA route table. Okay, I can give VPCA route table. I can save this. So next I'm selecting this. I can see details. I think this is the default one. Okay, we can leave it. I can select this one. It is VPCB. I can give this one VPCB route table VPCB. Now I will select this one and uncheck down. See VPCC. I'll name this one as VPCC. VPCC route table. Okay, done. This step also we have completed. Navigate to VPCA route table and click on the routes tab. Click on edit routes. Okay. So each and every route table we need to edit the routes now. VPCA route edit route. If you go VPCA, we're gonna edit routes, and we can have here the destination, and we can put add route 000 internet gateway. So we can put VPC internet gateway. That's what they mentioned. Yes. So like how we can say, like for VPC route table, right? We just attach to the internet gateway. Whatever the route table, right? We have, we can attach this route internet gateways to the particular route tables. Same association. In the same way, we can go this B, click on it, edit route, add route. Here internet gateway. This is a B, so B internet gateway. Save changes. The same time route table C. Click on it, edit routes, add route, 0, and internet gateway, and put VPC. So we have attached our internet gateways to the route table as well. So repeat for VPCB, VPC also we have done that. So now what they are saying, deploy EC2 instances in VPCs. Okay, create an IAM role for EC2 instances. So before that, they are saying like we need to create an IAM role for EC2 instances. Okay, we'll create that. This step will create an IAM role for EC2 instances to use. Okay, first thing, we're gonna go to the IAM dashboard. I'll go here. Maybe I'll take IAM. I'll search here IAM. It will open a dashboard for me. So in this particular dashboard, we're gonna create a role, create role, create role. Next, so under common use cases, click on EC2. So AWS services, we can give click on EC2. Okay, AWS services, we can click on EC2. Done. After EC2, click next. So we need to have this one. Amazon, we need to select this one. We can click next. Once we select this, we can click next. And in the permissions, maybe we need to check this one. Yes. So Amazon SSM, Amazon SSM managed instances core. Okay, we have to add this. So I'm adding it. And add permission. Next. Okay. Next, what it is saying. Next. Enter role name as ECS. This one role name we have to give this particular name EC2S SMIAM role. This particular name we have to give. Okay, create a role. This is the name that we wanna create, and verify the policies are listed. So this particular policies are listed here. So if you see this one listed, like add permissions, trusted entities, add tags. Okay, fine. So create a role. So AWS S3 full access also they mentioned. We'll see that. AWS S3. So AWS S3, we just mix this one. We'll also add to this. So now we have role name, we have S3 full access, this one also done. Create role. So we have created a role. This is the role that we have created, right? Okay, done. So now we're gonna launch EC2 instances. Okay, we're gonna go to the EC2 the console and we'll launch. Here we can say EC2. So why I'm going each and everything, right? Like we are following this particular demo, so whatever the details they mention, we need to follow it so that like we can get clear output. And how we can launch instances, you might already aware of launch instances. We have videos how to launch instance, everything we have videos. Okay, EC2. So launch instances and you can name the instances EC2. Okay, this particular names you can give it. And from quick select an Amazon Linux. Okay, Amazon Linux machine we're gonna see. Click start. So choose this one. We need to choose this one, Linux AMI HVM. Okay, 64-bit, like free only. It is like freely available. This one, this particular instance is freely available. Freely available. T2 to micro key pair. So here what they mention, there is a mention like scroll down to the key pair login, proceed without a key pair, not recommended. Not like you will be use SSM session manager to access the shell running to the EC2. So a key pair is not needed in the lab. Okay, we don't need a key pair. So that is what they mention. So scroll down to the network settings, click on edit. In the network settings, what we're gonna see, we're gonna edit. So what they're gonna mention. So VPC, which VPC we're gonna launch this particular EC2 instances. So VPCA we need to launch it, and the subnet VPCA AZ1 is a subnet we're gonna launch this particular EC2 instance. Okay, we do that. So it is in default. So we need to change to VPCA, and the subnet also I just changed it. Like here we have two subnets inside VPC, like VPCA AZ1. And auto assign a public IP, it's by default it's disabled. We just enable it. So we just enable it. Scroll down to the network section and firewall security group. Create a security group. Name the security group VPC AEC2 security group. Okay, we need to name the security group. Create a security group. Security group name. We just give this particular name. Okay, create a security group. Security group name is this one, allow ICMP traffic dimension. Okay, so we have one connection. Maybe we need to add this is security group ICMP. So the description we just mentioned, allow ICMP traffic. Allow. Okay. So now what we're gonna see here, custom. I can say source custom type. All ICMP IPv4 we need to select. Okay, ICMP all. Next custom, and we're gonna select 10.0. Okay. This one we're gonna select it, okay, and then that's it. Scroll down, expand the advanced detail section for IAM instance profile and choose this particular IAM role for the dropdown. Okay, we're gonna select this one, advanced detail. Not here. We're gonna go to the advanced details domain IAM instance role, and then scroll down, click on launch instance. Okay, we're gonna launch instance. I think that's it. Launch instance, launch two more instances and assign the names accordingly. Okay, got it. Just launch the instances. In the same way, we need to create two more instances for VPC B and VPC C. Give me 1 minute. Yeah, again launch instances, same way. The names according to here, we just, this is also filter eligible, T to the micro, proceed without a key pair, network, VPCB, availability Z1, good, and enable security group. Security group name, like naming conventions, we have to follow it. That's why I'm just checking the security group. So previously we just mentioned VPCA, now we are mentioning VPCB, EC2 security group. The description, okay, just see the description. Here, what is the description they mentioned? I see allow ICMP traffic with the, and we can add a security group role IPMP4, and here they just mentioned what the mention this particular role. So, so one VPC in AZ named EC2 VPC AZ1, and another one in VPCC AZ1 named VPCC. After few minutes, you can see this. And note down the private IP addresses assigned EC2 instances by clicking on their navigation to the tab. Okay, private IP addresses, note down ESCOM and okay. Then test internet connectivity, VPC communication. Okay, fine. Okay, we can do this. Advanced section. We have here IAM, this particular one. I think that's it. IAM, this is only one. The custom, this one, security group, allow ICMP all. I think that's it. Launch. Second also we are doing it. We will run third one now for VPC C. Sorry, the name you can get it here. That's security group one. Proceed without a key pair. Network VPCC and VPCC agent 1 enable. So security group name we have to give. I will do that. Security group name I have here. So the same naming conventions I'm just following. So I can put here. So this is VPCC, right? So according to that naming convention, I'm just creating this. And here also allow ICMP traffic. Got it. And we can add security rule here, and we can allow ICMP4 here in the advanced details. You just need IAM. That's it. You can launch third instance as well. We see the instances. So I can go to the EC2 instances, dashboard, instances. Why we are not able to see any instances? Just refresh it. Okay. See, we can able to see the instances VPC to VPC A, EC to VPC B, and EC to VPC C. So it is pending. It might take a couple of seconds to create that particular instances. Okay. So what they mentioned after that. So once we create VPCs, like we can get like this 3 instances. So note down the private IP addresses of assigned EC2 instances by clicking the instance navigating to the network table. Okay, we can take the IP addresses of each instances in each VPC subnet level. We can take the private IP addresses like this, but it will take a couple of seconds to come all the instances in the running state. We'll wait for that particular time. Okay. So once copy the following table with information to your favorite notepad tool just for our reference. Maybe I can copy this. So based on that, I'll just edit it. However, we have based on that, I'll just edit it. Okay. So we have VPCA, VPC. Okay. We'll check that. The private IP addresses, I can take it. Okay. So this is documentation. Okay. We'll go to the actual page to get the EC2 instances. Okay. So VPCA, I'll click on it. Click on this. What is your private IP4 address? This is a private IP4 address for VPEC to VPCA. Okay, I'll copy this. So I'm gonna paste here. For VPCB, we're gonna check now. So VPCB as well running. So we can take this one for VPCB. So VPCC. So VPCC is this. Sorry, this is VPCC. VPCC is this one, VPCC. Okay, okay, we just verify it. Okay, VPCC ending with 45. Okay, VPCC ending with 10.2.45. Good. VPCB, what we have in VPCB ending with 78. 78, good. VPCA 199. VPCA 199. VPCA 199, good. All this correct. Okay. We have taken the private IP addresses of the three EC2 machines and different virtual private cloud. Okay, fine. Now we need to do test inter VPC communication. We need to test inter VPC communication, it seems. So select EC2 VPC AZ1 and click on connect. Okay, we can select VPCA actions. Click on connect. So one step, second session manager. We're gonna go to session manager. So we can say connect. Terminal session should open a new browser. Okay. From EC2 instance VPCA, try to pinging the private IP addresses of EC2 instance VPCB and C. So what they're saying means, so you just connect here and we're gonna ping. I'll just open here. So we have three missions, but three missions are in different VPCs. VPCA, we have one EC2 instance, VPCB, one EC2 instance, VPCC, one EC2 instance. So what we're gonna do now, so this instance is running here, like we are able to see it side by side, but these are ideally in a different virtual private cloud and different availability zones. So we just connect to VPCA EC2 instance. From here, we are trying to ping this one, and from here, we are trying to ping this one. So from VPCA, we are trying to ping VPCB EC2 instances, and from VPCA, we are trying to EC2 instance in VPCB. We need to check whether the connectivity happened or not. Okay, we do that now. So what we're gonna do, we're gonna connect to VPCA EC2 instances now. Okay. So this is VPCA EC2 instances. This one. Okay. So as per the documentation, so what they're saying, they are asking to ping. So we are connecting EC2 instances on VPCA. So if you go here, what they are saying. So you have VPCA, you have VPCB, you have VPCC. So in each VPC you launched EC2A, just EC2B, EC2C by using session manager. We just log into EC2A in VPCA. So we log into the one session manager. Like what is this? This is the first VPCA EC2 instance. We just log in here, and from here we are trying to connect this EC2 instances in VPCB and this EC2 instance in VPCC. So we'll try that. So what the command, ping and the IP addresses, private IP addresses. So I copy this one, like why, because this is a B, right? So we are trying from A right now, A to B. Okay. So maybe I can put it here, VPCA VC2 instance A. We are trying to connect VPCB EC2B first. Connection request, like output we can check what is output. Next also VPCA, from VPCA EC2 instance A, we're gonna connect to VPCC EC2C, and we're gonna check from what is the output of the test file. Okay, so we can take this one. ping, paste. Okay, so I'm pinging from my VPCA EC2 instances to VPC B EC2 instances. Okay, we'll try whether the connection happening or not. It's not happening. It's not pinging. See, it's not pinging. I'll just say so. 19 packets transmitted, 0 received, 100% is packet loss. So if you keep on saying like it will have a timeout issue, but it is not happening. Connection is not happening. Why? Because we are having this machine is different VPC and different availability zone, and we are trying to have a communication with different VPC. That is the reason we are not able to access like communicate with other EC2 machine in VPC. So that is the reason. We'll try this one also. So here we got data loss. So we can check here as well. So we can copy this one. We can check now ping and this IP VPCC IP VPCC EC2 instances IP. We are trying to check it whether we can have established connection between VPCA EC2 instances to VPCC EC2 instances. I can say here also data loss. Same data loss. Okay. So now we can understand we are unable to communicate from EC2 instances resources from one VPC to another VPCs. So why do you think these things? Like why do you think are those addresses are unreachable? So that is what like we have next concepts called VPC pairing. So VPC pairing connection is a network connection between two VPCs that enable you to the route traffic between them using a private IP4 address, IP6 address. As of now, we are using IP4 address. So what they are saying, so VPC pairing will establish a connectivity between two VPCs. Based on this VPC pairing, you can able to communicate resources inside in your VPCA to resources inside your VPCB, and the same way resources inside your VPCA to resources inside your VPCC. So you can have established the peering connection so that two VPCs can securely communicate with each other VPCs. The resources, whatever the resource available in VPCA, we can have a communication to VPCB resources and VPCA also to have a communication with VPCC resources. So we'll do that. So in this lab, we're going to establish VPC pairing links to VPCA and VPCB as well as VPCA and VPCC. So we're going to create two pairing connections. So like VPCA to VPCB and VPCA to VPCC. Okay, we do that. So set up VPC pairing. So create VPC pairing. First thing, we need to create a VPC pairing. We can go to here, VPC console. If we go here, VPC console, we have a pairing connection. Can check VPC pairing. So pairing connection. Create a pairing connection. We follow the documentation and we do it. So first thing, VPC pairing connection. Create a VPC pairing. Second step, third step, specify the pairing connection name. So what name? VPCA and VPCB we can say. So like that we can put VPCA. The names like VPCA and VPCB are establishing the connection between VPCA and VPCB, right? So we can put that. Select a pairing with VPCB. So you can pair with my account or another account, like maybe VPC with a different account also you can pair, and you can pair different region VPC also. This region or another region, maybe it's have interview question. So you can do VPCs with same account, different account, or same region, different region. VPC ID acceptor. So what we gonna do here? We read it. So specify the VPC connection name. Okay, we just mentioned the name also. Under select a local VPC to pair with. Select VPC ID as a VPC requester. Select fourth point. Select a local VPC to pair with. Select VPCA as a VPC requester. Select a VPC, another VPC pair with my account. My account, okay. After that, VPC for VPCC acceptor, select VPCB ID. So I just selected here local VPC as the just mentioned here. Select a VPCA as a VPC requester, right? So that is the reason I just mentioned VPCA. So I think all set, and you can create a connection. And then the pairing connections, you can see pending acceptance. So select the connection, navigate to the actions, and click on accept the request. Actions, actions, accept the request, accept. So now it is active. So VPCA and VPCB, I have established a pairing connection. VPCA and VPCB. So this is the two VPCs. The same way, VPCA, VPCB. So in the same way, we need to establish connection between VPCA and VPCC. Okay, we do that. The same process, VPC pairing, create a pairing connection. VPCA, VPCC, VPCA, VPCC. Accepted. Yeah. Actions, accept request, accept. So if we go here, pairing connections. So I have two pairing connections. Okay, VPCA to B, A to VPCA to C. Now update the route tables. So we need to update now route table. Select VPCA route table. Click on routes tab. Okay, we need to update route tables. Routes tab. Route table, VPCA route table. So what we're gonna inside the routes. Third inside routes. What we're gonna edit routes. And fourth, we need to add this particular routes. Okay. So add routes entries for VPCB and VPCC using CIDR range, okay, respectively. This particular CIDR range, we need to add routes for VPC B and VPCC. Same way, we update the route table for VPCB as well. I'm just mentioning the routes. I'm just adding this particular route. Okay. A to B. Okay, fine. Save changes. Again, this route table, VPCC, routes, edit routes, add. So this is the range from VPC VPC Perring, VPC A to C, A to C. Okay, save changes. Done. So check the EC2 connectivity in VPCA. Now proceed EC2 console. Connect to the EC2 instances in VPCA using connect button in same way like how we have did in previously. In the same way we need to check now. Like we'll do that now. EC2 instances. Maybe you can go to here and from VPCA EC2 instances connect session manager connect. I'll close this. So I have already the IP addresses like VPCA. This one I have already right. So after we establish peering connection, we can see. Note down the result here. So you see, we are able to establish a communication between these instances like VPCA EC2 instances to VPCB EC2 instances. We are able to establish the communication. So the 14 packets are received and 14 packets are transmitted. This is success. So why? Because we have established a peering connection. So that is the reason it got success. So data transmitted. Data transmitted. We got success. So now here also we try this one. Ping. We paste this. So same way we are establishing connection between A to C as well. Okay. So now we're gonna to go to the documentation. So we can read if a peering and routing are configured correctly, you should be able to ping both instances. Connect to the instance in VPCB and can you ping instance in VPCC? What they're saying like so here what we have done. So from A to B we established and we tested peering working fine. And A to C also we established peering connection, it is working fine. But B to C, did we created anything? We didn't create it. That is what they're asking to check. So we connect to the B and we try to ping the EC2 instance in C. Okay, we'll do that now. So EC2 instances. So what we need to do, we need to connect to the B, connect session manager B. I'll close this. So what we need to do, from B we are trying to connect to the C. Okay, ping, this is B mission, so I need IP address. This is B mission, right? So from B mission we are trying to connect to C mission. Ping C. Whether it is established communication or not? No, it is not establishing a communication. Why? We don't create any VPC pairing connection in between VPC B and VPC C. That is the reason we don't have a communication between these two VPCs. So for that, what is the solution? We have a next session, how to establish a communication multiple VPCs. Okay, we do that. We see. So here we didn't establish any communication from VPC B, VPC C. We didn't establish any communication. So that is the reason it is not communicating. EC2 instances in VPC B not able to communicate EC2 instances in VPC C. Okay. So now with that, like, we have a next lecture, transit gateway. So what is a transit gateway? In this previous section, we have created VPC pairing links in order to facilitate connectivity between two VPCs. Yes, we have done that. So while this approach can be used in interconnect many VPCs, managing many point-to-point connections can be like it's difficult. I can say, like, like if you have two VPCs, okay, but n number of VPCs, we can't establish each and every connection, managing route table edits and everything. It would be painful. So for a more scalable approach into the utilization, you have AWS Transit Gateway. So in this lab, we will remove point-point peering connections between VPCA and VPCB, VPCA and VPCC. Next, you will set up a transit gateway and use it uh, inter interconnect VPCA BC. So in between this, like, we're gonna remove all this connections, and we have a AWS transit gateway. So this transit gateway in the diagram, if you see, so by using this transit gateway, we can establish multiple VPCs communication. Like the resources in VPCA, you can communicate to VPCB. The resources in VPCB, we can communicate to VPCC. C resources A, like multiple. Like if you have n number of VPCs also, by using this AWS Transit Gateway, we can have established, like, one time if you create it, you can establish multiple VPC communication. That is what they are saying about it. Okay, we do that. So delete peering connections. First thing, we need to delete the peering connections. Okay, we do that. So I'll close this one as well, and this one as well. I'll go to the peering connections. The first thing, peering connections, select VPC and B, delete VPC peering. Actions, delete VPC peering. And select checkboxes to delete route table entries to avoid the traffic a black hole filtering scenario. Delete related route table information also. We are just trying to delete, and they can say mention delete. That is what they mentioned. Delete related route table entries also. They just mentioned it. We're gonna delete route table entries also. Yes. So deleted. Repeat the deletion VPCA to B. So same this one also. This one also we're gonna delete. Actions, delete. Here delete route table entries and delete. Yeah, we deleted two of them. We deleted. Fine. So now set up a transit gateway. Transit gateway, why we use to establish a communication between multiple VPCs. We can use a transit gateway for one to another. We can use VPC pairings, but one to many, we can use a transit gateway. By using that, we can establish a communication between the resources in one VPC to another, or like A to B, B to C, C to A. We can do that. Okay, okay. Create a transit gateway. In the transit gateway, so just like 1 2 steps, we can go to the transit gateway in the VPC transit gateway. So create a transit gateway. We need to give the name. What name we can get? Transit gateway TZW. TZW transit gateway description. So immersion day transit gateway. I'm just following, right? So that is the reason I'm just using same immersion day TZW. Next, configure the transit gateway. So we can say configure the transit gateway. So this one, what is a few moments later, transit gateway will be from pending to avoid. Okay. Amazon side autonomous system number ASN. So I can see this 64512 64512 64512. I have given this number. Configure the same way I have configured. Create a transit gateway attachment subnets. I think that's it. Okay, 1.1. I can create it after few minutes. It will create it. Dimension. Okay. You can see it is pending. Next, 2.2, 2.3. Okay, fine. We follow these steps now. So create a transit gateway attachment subnets. Okay, navigate to the VPC subnet. Create 2 subnets for VPCA, one per AZ. Okay, for transit gateway, we need to create 2 subnets. That's what they mentioned, like creating subnet for a transit gateway. Create 2 subnets VPCA, one per availability zone. Create 2 subnets VPCB for one per availability zone. Create 2 subnets VPC, one per availability zone. Okay. So previously we have created 2 subnets in each VPC, right? For additionally, we are creating 2 more subnets for this transit gateway alone. So we follow this documentation, we will create it. Okay, create a subnet, VPCA, the name, dimension, VPCA transit gateway. We can copy paste this, and this is the range, ADR range. I'll just use the same range. That's it. 16 IP addresses, it is allocating 16. Create a subnet. And another one, create a subnet. A, the name, this is also allocate 16 IP addresses. Create subnet. So in the B now, VPCB, we're gonna create subnet. One more subnet. VPCB, this is the name. I think I missed to select the availability zone previously. Let me check that availability zone. 1A. Okay, availability zone 1A. This one, availability zone 1B. Just created. Okay, fine. 1A, 1B. It is created. 1A and 1B. Fine, no problem. It is created. Here, VPCB. The name, what is the name? VPCB. This is the name. I'll just mention the name and availability zone 1A CIDR block range is this one, and create. That's it. Next, we can create one more subnet, VPCB. Name is this one, 1B. What is CIDR range? This is the CIDR range. Fine. So it will allocate 16 IPS. Fine. 3. Create subnet, VPCC. This one, VPCA. This one. Create subnet, VPCC. Create subnet, VPCC. This is the name. Availability 1B. And finally, the range 16 IP addresses. Create subnet. That's it. I think we created all the subnets for TGW as well. Oh, sorry. So if you see VPCA 2, VPCB 2, VPCC 2. Fine. So now in the third 2.3, transit create a transit gateway attachment in VPC dashboard, transit gateway, navigate to the transit gateway attachment, create transit gateway attachment. Okay, we can click on transit gateway attachments. Click on transit gateway attachments. If you go to the transit gateways, transit gateway attachments, so you see attachment. Okay, this one. Type PC, PCID, subnet ID. Just VPC attachment, create transit gateway attachments. 2.3, create a transit gateway attachments, transit gateway attachments. After that, create transit gateway attachments. We have a name tag and DNS support enable and VPC ID subnet IDs. VPC ID, VPCA, VPC is 1A, 1B, VPCA. Okay, we are attaching A, and then repeat these steps. Okay, so we can create a transit gateway attachment. The same way we can create it here, and we can say name. What is the name? We got VPCA, right? VPCB attachment. We can put VPCB attachment. This one VPC you can put B, B, and then create transit gateway. And VPC, VPCC attachments, transit gateway. and VPCC, and 1A, 1B, C. Okay, now VPCC. Okay, just create transit gateway as well. Three, three transit gateway attachments. You can see. Mm. Now, what we need to do? Repeat the steps for P and C. We have done that. Upon completing, we should see three transit gateway attachments. We are trying to see that. Okay, three. VPCA, BC attachments. Fine. We're able to see three. Check the transit gateway route table. So transit gateway route table. We have to check the transit gateway route table. Transit gateway route table. Select this. Choose in the routes what we need to mention in the routes, like then you should see the route table, click on it and click on the routes tab. Okay, your route table should be populated with VPCA, VPCB, VPCC routes. Okay, we need to add this VPCA routes, VPCB routes and VPCC routes. Okay, we can add that routes as well. In the route table, go to the routes and routes. Create a static route or what, how it is create. There would be maximum 1000 routes. You can create a static route. Okay, so you can create route, static route. So you can have VPCA, VPCB, VPCC. /16. Yes. Edit routes. This is a different one, right? Okay. This one we just need to add this. Fine. CA. Routes. So here we created one static route VPCA and we're gonna create one more for VPCB. What is that route? Like 10.10016. 10.100/16. This is VPCB and VPCB attachment. Create a route and create one more route. This one. No, here set gateway routes. Create a static route. And what is the range? 10.20016. 10.200 slash sorry slash 16. Okay, fine. I just created this active and C. Okay, I just created route this one as well. So I've created routes. So three routes in the route table. Update the route table of VPC. So we need to go to the VPC's route table. We need to edit the routes for VPC. VPCA, we need to do that. VPCB, VPCC. Like what we need to do? 1, 2, 3, and 4 in the route table. What information we need to edit? Edit routes. So in VPCA, we need to put add routes for VPCB and VPCC. So your VPC is route table. So route table for VPCA, route table for VPCA. I just click on it and edit routes. Um, edit routes. We just maintain this one. Add routes. 10.0.0.0.8, and we can mention transit gateway here. Transit gateway. PC attachment. A bit confusing here. We just like so here we just go to the route tables of our VPC in the routes, edit routes. Okay, we just go here, add routes for entries for VPCP and VPCC. So to simplify configuration, create a single routing point to the transit gateway. Single routing point to the transit gateway. Hint: this works because the local routes is more specific. So therefore, 10.0.0.16 will traverse the more specific local route to the VPC. Anything other than other traffic will traverse to the less specific. Okay, fine, understood. Repeat the steps for same for VPCB and VPCC route tables. Okay, we do that. Here, just mention this and save changes. The route table, you just click on it, and VPCB route table, you just click on this route table, edit routes, add 10.0.0.0/8 here, transit gateway here, B, and save the route table, C, and edit routes, add 10.0.0.0/8. Then we have a transit gateway, and then VPCC, save changes. So now we have done. Check the EC2 connectivity via transit gateway. Proceed EC2 VPCA and ping IP addresses deployed in VPCB and VPCC. Ping should be successful. Connect to EC2 B, and then like okay, we need to connect now. So what we need to go to EC2 instances. Sorry, EC2 instance. I can check here. Already we have launched a couple of EC2 instances, right? We can go here, VPCA, and I can click here, session manager, I can connect. So ping, I have a notepad. From here, I log into the VPCA, so I'll just try to connect VPCB instance. It should work. Okay, it is working, fine. So now ping from A to C, I will check. So A to C also it is working. Now I will log into B. From B I'll check A and I'll check C. Okay. So I'll go to the instances. I'll log into the B. I'll click on that. Connect. Session manager. I'm going to log into the VPCB. I'm trying to connect EC2 instances in VPCA. From B I'm trying to connect to the A instances. I'm trying to ping From B it is also working. From B I'm trying to connect to the C. Ping. It should work now. Yes. So we're able to establish a connection between everything. So multiple connections. A from A, if we log in here, A to B we are able to ping, and A to C we are able to ping. So if we log into the A to B we are able to ping. So A to B we are able to ping at the same time. A to C we are able to ping. And if we log into the B to A we have pinged, and B to C we have pinged. If we log into the C as well, C to A we can able to ping, and C to B also we can able to ping. So by using this transit gateway we can establish connectivity between the multiple VPCs, so that like the resources inside our VPC will able to communicate different VPCs. Okay, got it. So with this we're gonna complete lab 1. So whatever lab we have, right, like we have completed this lab 1 session successfully. I hope this will be helpful video. Okay. So 1.3 like we have done, like things should be successful. Create like we have tried this 3 and 4th points and it is successful. You can see the previous demonstration. These two things are successful. Now it is very important, like whatever we have created, the cleanup thing is very important, right? Because to avoid unnecessary cost we need to clean up this. So make sure you have terminate delete the resources below to avoid unnecessary charges. Okay, step by step we have to delete transit EC2 instances, delete transit gateways and attachments, delete the VPCs what we have created, delete IAM role and finish. Okay, we can follow step by step. We can delete it. So terminate EC2 instances. First we need to terminate the EC2 instances, like EC2 instances we need to terminate it. We do that now. So go to the instances and we select this instance date, terminate instances. Terminate. So successfully terminated. EC2 instances successfully terminated. Okay. Next. So EC2 instances we have done successfully. Terminating is done. That is step 1. Delete transit gateway and attachment. Okay, delete transit gateways and attachment. How to do that? Here we can go to the transit gateways and delete, 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 delete. So we can go to the transit gateways. So this is EC2, right? Like VPC, we can go transit gateways. We have to navigate to the transit gateways to delete that. Transit gateways attachments. So A, B, C actions. Okay, one by one maybe we can select actions. So delete transit gateway attachment. Delete. So now B action, delete, delete, delete. Now C, delete. Done. We have deleted A, B, C. Deleting. It's going to delete. Like it will done. So transit gateways we have deleted once all the transit gateway attachment. Once all 3 transit gateway attachments show the state deleted, navigate to the transit gateway console and click on delete from the actions. And once we deleted, it's deleting, right? Once it is deleted we can go to the transit gateway console to delete this transit gateway. Actions, delete this transit gateway, delete. So first we need to delete the transit gateway attachments. After that we're gonna delete the transit gateway. While you are creating, first you need to create a transit gateway. After that you need to create a transit gateway attachments. Okay. So we have delete the VPCs. So three VPCs we need to create. We have to go to the VPCs and VPC delete, and subnets also we have to delete. Okay, we can go to the VPC now. Your VPCs. So VPC A action delete VPC. So associated things also I'm gonna delete everything. So VPC B action delete P VPC also it is gonna delete now, and VPC C delete VPC C also it is going to delete now. So three VPs we deleted. So now we need to delete the IAM role what we have created, right? This particular role we're going to create IAM dashboard. We can go IAM. So we can go to the roles. This particular role, delete, copy paste it, delete. Yes, done. We have deleted that particular finished. Once you have completed the above steps, you are finished. If you want to continue the lab 2 to 4 later, you will need to complete the lab 1 again. And do not clean until you finish with all the labs. Okay, fine, understood. So, like if you want to continue 2 to 3, 4 labs, right? Like we create the setup again. So maybe we do that later, but when we're talking about this particular labs, we have some cloud formation templates to do the automation, whatever we have done the manual actions as of now. So as of now, you can also do the practice for the particular lab 1 session. So with this, like we can learn like creating multiple VPCs, subnets, and then pairing connections and establishing a transit gateway, communication between one EC2 instance to another EC2 instance. We have learned all this in the lab 1. So thank you so much, guys, for watching my videos, and do share, like, subscribe my videos. And this particular video I have made because of the 12 weeks AWS challenge. So maybe might be like the video will be like couple of lengthy video, and it would be like it's not a kind of a basic video I can say. So in our channel we're gonna update the content basic from basic scratch to till advanced level. We're gonna do that. Like I'm gonna make that content readily available for you. So in AWS, each and every service I'm gonna work on it, and I'm gonna uh, work for you. So again, like I'm emphasizing, so if you wanna try to join this 12-week AWS challenge, like you can have all the links. I'll give the video description of my YouTube channel. You like this video, comment down and share your opinions as well. If you need any kind of a help, you can connect me on LinkedIn. My LinkedIn ID also I can show you. So here you can connect me. This is my name, Dharma Teja Siddhabattina. So you can just send me a request so that I can accept your request. We can have a discussion. Okay. Thank you so much. And with this, I'm going to end my video. And we're going to talk about lab 2, lab 3, lab 4 and later days. Thank you so much. Have a good day. Bye bye.